So far we know that when we're trying to solve a system of equations by graphing, what we do is we graph our two lines and we're looking for the place where these two lines meet. There's going to be a problem with this though sometimes, and it's going to kind of call into question, is graphing the best method to solve these all the time? So what I'll do is I'll go ahead and we're going to graph both these lines and see what a problem or what problems can sometimes arise when we use graphing to solve a system of inequality or equalities. I'm sorry. So what we'll do is we'll graph both these lines. I'm going to start, again, this would be telling me to start at 0, and our slope is 1, so I would be going down 1 and right 1. So this would be our first line. I'm going to extend this out for a little while. And then we'll connect our dots. Okay, so that'll take care of the first line. Now we're going to try our line in blue, and we're trying to look for the point where these two lines cross, because that's going to be our solution. So I'll go down to -2, and I'll go up 1 and over 2 and connect my dots. And you can see here, oops, you can see here that these lines are already going to cross here. I'm just extending this just to make it look a little nicer. And you might see a problem has arisen here. When we look at these two lines, they don't really cross at a nice even point. They cross somewhere in between there, and we're not really sure exactly where that is. Is it, is it -1.5 for our y value? Is it, +1.5 for our x value? Is it something over 4? Is it over 3? We have no clue what that fraction is going to be just by looking at our kind of quickly sketched graph. So we're going to have to find an algebraic way to solve this so that we can get the solution. And actually, most of these algebraic ways are much better for solving a system of equations than actually graphing them. So let's go ahead and look at how we solve a system by graphing. And I'm going to talk about all these steps when I get to an example, but I'll run through them briefly here. The first thing you want to do is in one of the equations, isolate a variable. It doesn't matter. I know we've always been isolating y when we're graphing lines. It doesn't actually matter if it's x or y in these equations. So in one of the equations, isolate x or y. Then what you're going to do is substitute the one equation into the other. You're going to plug one into the other, and you should only have one variable left, so we're going to solve. Finally, you're going to get an answer like x equals 2 or y equals 3, and whichever variable you know, you're going to plug it into one of the equations from the beginning to find the other ordered pair. So if you have the x, you plug it back into one of the equations to find the y. And then finally, since we're looking for where the two lines cross, you write your answer as an ordered pair. So let's go ahead and try one out. Okay, we've got x equals 3y, and then we've got 2x plus 4y is equal to 28. Now, our first step is to isolate a variable in one equation. And actually, if we look at our variables over here, we actually already have a variable that's isolated. If you take a look here, that is already isolated. So I like to put a box around that. That just kind of helps me around the stuff that's equal to x. So that's done. Here's the trickiest part for people who are just learning this. We need to substitute one equation into the other. Since x is equal to 3y, what I'm going to do, since these are the same thing, if x and 3y are the exact same thing, I'm going to replace this x over here in the second equation with a 3y. Okay, so what I'm going to do is I'm going to write the exact same equation, 2 times something plus 4y equals 28, and all I'm going to do is replace the x with a 3y because they're the same thing. And now from here it's just kind of solving the equation. So I'm going to take 2 times 3y to get 6y, so we get 6y plus 4y equals 28. And then if I go ahead and add, we get 10y equals 28. And then if I divide by 10 on both sides, I'm going to get y is equal to 2.8. Okay, so that should get us our first answer there. So we plugged the equation in and we just solved. All right, and we got y is equal to 2.8. Here's what we know so far. I know that the y coordinate where these two lines will cross will be at 2.8, but I don't know where on the x-axis they're going to cross. Well, not really on the x-axis, but where these two lines would cross for the x-coordinate. So what I'm going to have to do is take your 2.8 and pick either equation and plug it in. It doesn't actually matter which one you plug it into. So this 2.8 here, I personally think this equation's a whole bunch easier to plug it into. You could plug the 2.8 in here and solve for the x, but why not just do this one, because it's going to be a whole lot easier. So it'll be x is equal to 3 times 2.8. Okay, and if we triple 2.8 here, we got 2.8 times 3, that'll give us 24. Carry the 2, 3 times 2 is 6, that'll be 8.4 for our answer here. So we're going to have 8.4 for our x. And now when we do this, again, this will be the final step, is to plug this 8.4 in. That's the x coordinate. We now have found where these two lines cross. They cross at the point 8.4, 2.8. Move on to another example here. Okay, there are other methods to solve these, and later on you'll actually probably find a way that you might like better to solve a system like this. But for now, we'll use substitution. Okay. The first step will be to isolate a variable in one equation. Now, there's good variables to isolate and bad variables to isolate. Typically, if I see no coefficient in front of the x or the y in one of the equations, that's the one I'm going to isolate. So I'm not going to try to isolate this variable, and I don't want to try to isolate this variable, or I'm going to end up with some kind of ugly fractions and decimals for, some of these that might make it a little bit harder for myself. And, in this case, it's not too bad, but there are some problems where you'll make your life kind of miserable if you don't pick a good variable to solve for. So these two probably aren't your best choice. There's no number in front of the y here or the x here, so let's isolate one of these. Okay, so we'll look at the x and y. We can really take our pick here. I'll just isolate y on this one. I isolated x in the last one, so why not? And I'm going to rewrite this as y is equal to, you could do 9 minus x, just because we're used to slope-intercept form, I'll do it this way. It doesn't really matter. But and what I'm going to do now, since the y is now isolated, we're going to substitute this stuff, the stuff that y is equal to, in for y in the other equation. All right? So if we write this equation down, again, I'm going to write everything in this equation exactly the same. I'm going to write 4x minus 5 times something is equal to 10. Notice I put parentheses here because we're going to have to multiply that negative 5 times this whole thing right here. Okay? So I'm going to start by bringing my 4x down and distributing this negative 5. So we're just going to solve this like a regular equation. That would give me positive 5x minus 45 is equal to 10. Alright, so far, again, flip the sign, 45. Now over here we're going to get 9x is equal to, and if we add the 45 to the other side, we should be getting 9x is equal to 55. And if I divide by 9 on both sides, I'm going to get that x is equal to, we'll leave that as 55 over 9 for now. Okay, so that'll take care of our first ordered pair. 55 over 9. This is the x coordinate, so it's got to go in for the x. And you can't put it in for that ordered pair. That's the y. Again, you can pick one equation here. See if you can find one that you think is easier. I probably would think, again, that the top one's going to be a little bit easier here for us. So I'm going to take this x and plug it right into the top equation for x. So I'll replace that x here. I'm going to keep everything else the same. And I'm going to replace this x with a 55 over 9. So 55 over 9. And then just to get this into a common denominator where I can subtract this, let's make this 55 over 9 plus y is equal to 81 over 9. And then if we subtract our 55 over 9 on both sides, we're going to get y is equal to, so if we subtract here, we get 81 minus 55. Okay, we subtract 11 would be 6, and then if we take one away, that would be 7, so it would be 26 here over 9 for our y value. Okay, so it would be 55 over 9 and 26 over 9 would be the ordered pair where these two would meet. If you're getting hung up on the fractions, don't get too worried about that. Again, sometimes they'll work out to be whole numbers, sometimes they won't be. It just depends on the problem. We got one more to go through. And this is actually the problem that we originally started with. So this was the, if I flip back here, this was the original problem we introduced this with, where the two lines crossed at some uneven point that we were trying to find. So I'm going to flip through here, and we'll look at y equals the opposite of x, and y equals 1/2 x minus 2, and we're going to have to figure out how to substitute. So actually in this case, both variables are isolated. So you can really pick one and put a box around. I'm going to put a box around this one. And what we're going to have to do, again, is plug this equation. Now this is where you have to be careful. Not in for x. Y is equal to this stuff. So this actually has to go in for y over here. If you have y's and x's after your substitution, you know you made a mistake. Okay, so we just got rid of the y, we plugged it in. And now let's get all the variables to the same side. So I'll subtract my 1/2 x over to the left here. And if I've got 1x minus 1/2 an x, again, if you make a common denominator of 2 over 2 minus 1 over 2, you should get negative 3 over 2. X is equal to negative 2. And then I'm going to multiply by the reciprocal here, which would be negative 2/3. So times negative 2/3. And we've got x is equal to positive 4 over 3. This will take me right to here. So the x coordinate, again, that's the one that's got to go first, is 4/3. Another way I could write that, again, would be 1 1/3. So you could also, this will actually help us in a little bit to check to see if it matches what's on the graph. Okay, so I got 4 over 3 here. And now I've just got to check my final answer. So to get this y coordinate, the first equation is just going to be super easy to plug into here. So I'm going to take that x and plug it in. Since y is equal to the opposite of x, if we plug that 4/3 in for x, then y is just negative 4/3. That's going to be really quick to find our y coordinate. Or again, I could write it up here as negative 1 1/3. So a few ways to kind of verify that our answer is a good answer. So in this case, since we had already graphed this one, I'm going to flip back, and I should see a little bit past 1, a little bit past 1, and a little bit down past negative 1. Our point should be where they cross. Okay, if I look at the graph, that should be about where they cross. A little bit past 1 to the right of the 1 here, and a little bit below the negative 1 here on the y-axis should be where we find that. And let's just check real quick. Yep, you can see that it's a little bit to the right of positive 1 in the x direction, and a little bit below the 1 in the y, negative 1 in the y direction. And we can see that that is going to make some sense here. It's all this stuff is connected. It's a different way to do the exact same thing we were doing before. The alternate way to check your answer, actually I shouldn't say alternate because this is really the best way, is to take your ordered pair, take in the x, and I'm not going to go through this whole thing just for the sake of time, trying to keep this video not super long. We could take the x and the y and plug them back in the original equation. So if we plug it back in here for x and in here for y, it should make a true statement. And you can't just check one. Here's the other thing about systems. You have to check both. Okay, if you want to check your answer, you have to plug it in here and here. You also would have to plug the x and y in here and here. It may work on one line, but not both lines. So you need to make sure when you plug these back in, it works in both equations, not just one. So again, solving systems using substitution, it's good when your lines don't meet at an even point. Graphing really isn't the best method to do this. Substitution is a much better method all around to use. There will be times you will use graphing, but it's more applicable when you're dealing with inequalities that you graph a solution set.